Hello, colleagues. I'm welcoming you here on this section, and be pleasure to present you a next topic, which is Kubernetes as a service. For any cloud, which means it will be some. I continually go to the topic which was already mentioned by presenter before me, when he was saying that our stack is consisting from application, infrastructure, and platform as a service. We will go look deeply to the second part, and this is platform as a service. Let's go. Okay, maybe for beginning, this is maybe known for you, but just start from the motivation, why we starting working on this project, or why we think this project could be interesting for others. You probably know that containerization of your application has many benefits. Yeah, it comes with isolation. Your infrastructure could be immutable, that if you once create some, for example, Docker image or some Dockerize your application, then your application will be the same. Doesn't matter when you deploy and how you deploy. It will behave the same, or should behave the same. It's faster. Yeah? Before, on the virtual machines or on the physical nodes, there was plenty of time takes for deployment and to make deployments the same. In containers, it's very easy because everything is predefined, everything is inside, and then you can, by maybe some parameters in the Docker file, you can deploy very easy your application and very fast. Versioning is also easy because it's based on images. As I said, easy to develop and deploy, and of course sharing, and it's because you can share somewhere nowadays in the open source community or in the GitHub if you have some important feature or application which could be interesting for others or maybe for business. There were also some challenges. You cannot run container in production in one node, yeah, because if one node goes down, all your production, everything what you have there is going down. Therefore, it was necessary to have multiple nodes and create the clusters which could be somehow managed. There was a Docker Swarm which partially solved this, or managers like Docker Swarm, which partially changes and fulfill these prerequisites. But problem is that it has no so much feature if you want to use for production, mostly for big customers. Therefore, Kubernetes got on the play. Yeah. What were the challenges before? Networking, which was working actually on the Docker, but maybe, or containers. I am using as an example Docker, but of course these container engines, they are more than Docker. Networking deployments, when you can control your deployments, have some self-healing strategy. You need also not only just bots, but maybe you need some special deployments, like daemon sets. It means in every node you need one pod because it's some service which is node specific, yeah? Or stateful set because you need some have some state about your application and so on. That Kubernetes brings many features and also persistent storage, access control, rollout possibilities different, yeah, like green, blue, or canary. And everything on the fly, which was on the classic IT, was very complicated to do it like this way. Okay, let's imagine that we are the customer, for example, from healthcare or from public, because these big customers, like with a big workload, like for example, in our case, could be like health insurance company, like in Slovakia, general insurance, yeah, which have millions of people inside and many data, many workloads, maybe applications, some internet, which needs many resources. What is the most common architecture of the Kubernetes is that have some master nodes, it could be 3, 5, 7, because of quorum, of course, and high availability, that should be more, and some workers where you have your load. Of course, there are more clusters because you have big loads. What are the possibilities? You can build your own clusters on your nodes. Yeah, you have nodes, even you create their virtual machines or just nodes, physical nodes used as a node of your cluster. There are, for example, normal Kubernetes cluster, K3s, Minikube, and any others. Then the second option is to use hyperscalers. We know already that most of the hyperscalers, I think all of them, but not sure, but definitely most of them provide such service, like AVS, AKS, Elastic Kubernetes Service, or OTC Container Engine, and so on. And then you can use also another option, that you have some kind of load, and you use some manager or some platform up on it, and this is, for example, OpenShift and Harvester. Okay, what are the disadvantages of these solutions, or what they are not covering? You cannot, or you can, but it's most complicated to install manually, cluster by cluster, manually, yeah? Like in normal way, if you need 100 clusters, for example, 200. When you go, for example, if you are a customer which has load in different public clouds or different hypervisors, it's not the same. They try to be very similar, but they're actually not 100% the same. Yeah, there are, for example, different limitations. Could be that they have different versions of the Kubernetes clusters. They have some specifics for per hypervisor. They may be for storage, or maybe they behave with storage differently, and so on. And when we talk about platform, which could be also solution, like OpenShift Harvester, you know that OpenShift creates some specific API, which is valid only for OpenShift. If you create application only for OpenShift, then maybe in the future, if you want to go out from the OpenShift, you need to rebuild it. If you are relying on their solution of some things, yeah, that's also not very pleasant if you want to be independent. And in this world, open source world, it's, I think, the most of the people or customers want it. Harvester is the similar, yeah, is the SUSE. Maybe they has not so much own solutions, but also you are kind of locked, vendor locked, because it's, I think, bought by SUSE currently, and also could have some own solution and some locking there. That's what they are not covering actually is security. My colleague was talking about that. Yeah, that's if you have something in the hyperscaler, talking about super security, it's very brave. Yeah, the security, you never know where your data are. You never know who, in which server, in which country they are running, or where they are stored. And in these days, in this geopolitical situation, many customers are asking, okay, who is working with my data? Who can access my data? Where are my data actually physically are located? Yeah. Then standardization. As I said, if you have, for example, a load, when you want some, for point of security, you want some load have in your data center, some load in hyperscalers, and some load in OpenShift for some reason, then you need many people who understand all these technologies and understand all these, your specific types of the load, yeah? Which is expensive, operational costs are higher, and so on. We want to be vendor independent. Yeah? Even if I am anywhere, I want to have the same features, and I don't want to have some specific feature which I cannot have somewhere else. And of course, as I said, complexity of operation. Yeah, this is the thing. What is our solution? Then I'm going slowly to this platform as a service that we know already motivation. What is consist? It consists in actually three layers: garden cluster, seed cluster, and shoot cluster. What is the advantage? Well, I will explain some of them later, but maybe to mention on the beginning is central provisioning stack. You have one point, even if you deploy 100 clusters, you have one point of managing it. Of course, there are multi-tenancy. It means you can have more stacks over for example, one stack per customer. Yeah? But this stack is controlled from one place, and doesn't matter when they are lying on which infrastructure. Garden cluster, you can have large-scale organization. We are counting that one seed cluster will cover maybe, I don't know, 100 shoots or more. Yeah, it depends on the customers and on the locality and the dependency. Also, what is the advantage? You can physically separate customers even if they are on the same stack, because the cluster workers are on different nodes, maybe also on different infrastructure, even if they have one central point, for example, for upgrading, monitoring, logging, and so on. Yeah. What is, I think, for customer will be big benefit is the same user experience or customer experience. Every cluster, doesn't matter where it's running, is behaving the same, looks the same, and has the same possibilities, same objects you can deploy, and same monitoring, same logging, and so on, which is, I think, the best. The same tools are used, extension in the Kubernetes cluster, and so on. That's the, of course, there are differences, but they are covered behind the scene, and there are some plugins which are communicating with hyperscalers or Garden on Metal, which was mentioned. Then on the higher level, on the customer level, on operational level, doesn't matter. Easier to administrate then, yeah? Multi-tenancy, what I said, you have one central point, but you can have more stacks, and then for every stack central point, you can be divided by location, could be divided by customer, could be divided by any other reason, whatever you want, yeah? Okay, and declarative approach. Why I mentioned, of course, Kubernetes is declarative, but not only the objects in the Kubernetes are declarative. For example, seed cluster is Kubernetes object of Garden cluster, that you can deploy cluster as an object, like applying YAML, yeah? Also, shoot cluster is just object of Garden cluster, and its administrating is in the Kubernetes way. For example, in seed cluster, machine, the virtual machine where is running the Kubernetes or control plane of the seed cluster, for example, and this machine is also Kubernetes object. Then if you want more worker, you just extend replicas of the machine. Yeah, just, that's the interesting way that everything which is there, every service, is behaving, administrating as a Kubernetes object, which you have one way how to administrate. Of course, you need to know Kubernetes and how it's working and so on, but then you can administrate anything, yeah? And what is advantage that should cluster, because actually customer, what he need when you think, if he have normal Kubernetes cluster, then customer actually need only put his workload. He don't need control planes. He need workers. Control planes are just cost for him. Yeah, because his load is actually running and his application is running on the workers. That's why, okay, let's put control planes not on the nodes, because every node is money. Even if it's hyperscaler, even if it's physical, it's cost, yeah? And everything in the business is about money. Also, Kubernetes was developed because of money, yeah? Because to not have virtual machines, to have just containers, then less containers, smaller, yeah, and destroying layers because of money. Yeah? And that he need worker. Okay, let's put control planes somewhere else. Why control planes or services of control planes could not be pods in the Kubernetes? That's why control planes of every shoot are just pods in the namespace of the seed. If you have 5 shoots, you have just 5 namespaces in the seed. And then if you need, for example, more than 3 API servers, because your load is big, just will make 5 replicas, yeah, 6 replicas, 7, whatever you need. Right? It depends of your load. For example, if it's some public web page, many people could come, yeah, 1 million or whatever. Then, if it's not so, like in the night, it could be downscaled, yeah, to 2 to 1 replicas, like in Kubernetes. And that's the idea why, of course, for big load, not for the small. If I need 1 cluster, it has no sense to create 11 or 12 machine to have 1 cluster. But if we talk about 100 clusters, 40 cluster, or 300 or whatever, then it's make a saving. Okay, let's talk a little bit about the Garden cluster. Garden cluster we can consider as a brain of whole stack. When you think about whole stack as a Kubernetes, then Garden cluster is API or control plane. You are talking as a user or administrator with Garden cluster directly. If you want to shoot, then just apply YAML against Garden cluster. If you need some service or whatever, then you talk about one cluster. There are more options already mentioned by my colleague. First one is dashboard, yeah, where you can easily deploy shoots or change shoots, delete shoots, configure through the YAML, or some small options also by dashboard. Then Garden CTL, which is alternative to kubectl, but administrating these objects which are special for Gardener, like machine deployment, like seed cluster. Yeah, there are no normal objects in the Kubernetes, but you can use Garden CTL. Then, of course, a Garden cluster could provide other clusters, services like DNS, SSO, yeah, single sign-on, maybe monitoring, and any other services which is needed for such stack, which could be used in the shoot cluster at the end. And of course, shoot objects, which are deployed and control, as I said, as a Kubernetes object. Then seed cluster. Mostly seed cluster could be divided, depends of many factors. For example, you can have different seed cluster per region, but mostly, what is important, every seed cluster could represent one type of the infrastructure. You can have one seed, you cannot have one seed which has shoot also in AVS and also in OTC. That's if you want, for example, 3 infrastructures type, then you need 3 seeds. Yeah? And then one customer, which is representing, for example, Garden cluster, one Garden cluster represents one customer, for example, then could have seed cluster in AWS, one cluster in OTC, and one in Metal and physical machines, Garden on Metal, yeah, which was explained a little bit or mentioned by my colleague before. And then his infrastructure could be collected in one way, and from his point of view, it will. One is not working? Okay. And he is just controlling it as he is used to. Yeah? The same way we'll control shoot in the AWS, and in the same way in Garden on Metal or OTC. And of course, as I said, seeds I already mentioned that they have the control planes of the shoots, that all the control plots which are needed or services are there. Of course, clusters. As I said, these 3 layers stack, it's only because of shoot clusters. These are the product which we provide to customer, that he has some space or platform when he can put his workload in different way. What is advantage? You can handle it as an object, as I said, control as the pods. Clusters are independent. You can have different versions of the clusters in the same stack. And doesn't matter how much replicas you have, what's the version, they are independently. They are not influencing each other. And of course, if we don't talk about seed cluster, on one Garden cluster, on one stack, you can have also different infrastructures. You can auto-scale control planes and workers, I mean on the seed cluster, Garden cluster, if it's needed. Yeah, because of course, these controls which are running on the seed are taking some resources. And if you need more resources, then you just also, the seed workers are in the seed cluster as objects. You just raise the machine deployment, it's called. It's like deployment in the pods. And then automatically we'll create machine in the, for example, hyperscaler, configure it, and join it to the cluster as a next worker. And you have, again, resources. It's taking 4 minutes, maybe 5 minutes, depends on the connection, depends on the hyperscaler. You know, there are some things which you cannot influence. And then you can have more shoots, and you can limit them. Yeah, how much? And also the shoots could hibernate, which means, for example, let's imagine that you have your workload in the hyperscaler when you are paying for every hour or every minute, every second, not sure on all hyperscalers how they are counting. Then let's imagine that you have something which are using the customer, for example, health insurance, has some application, which is BEP, and on the night, no one is logging there. Yeah, and it's has no sense to run it. For example, it could be attendance for his employees which are not working at the night, and so on, and these things. Then you can select hibernate shoot cluster, which means, and the current time automatically goes down, machine disappear from the hyperscaler, you are not paying for that. And when you waking up, everything will go up without any disruption, and application is up. And this could be set automatically. You know, scheduling something like cron. If you know Linux cron tab, then it's very similar. Yeah, that you set which hour, which day, and so on, and then it will work. When we compare, for example, if we have this is classic way how Kubernetes is working. Yeah? 3 masters, because you need minimally 3, and then workers. If you have 7 like this, cluster like this, you need 21 masters. If you just have shoots with 1 stack, and let's count that every stack has 3 workers, then you need garden, which is 6 machine, 12, then for 7 shoots, you need 12. And there is 21. Yeah? And this is, for I think, for customer, also one of the important things, besides the features and things, that he is not paying for 21 machines, but for 12, as a overhead, I mean. Of course, we have, in our solution, we have also a cluster which called central cluster, but this is not functional from point of gardener stack. It's just we having it for the central functions, like collecting monitoring from all management stack, from seed, garden, because we need to have monitor it, yeah, for operation administration and so on. Logging, because from security point you need to store logs for some times, yeah, depends of the logs. Then logging solution. Certification service. If your customer want to deploy some application, he need use the certificates and valid communication between different application. That also certification is as a service. Central SSO. He don't need to he can use his solution, or he can use something which is provided by seed or garden, and or from central cluster, and then connect our SSO solution to his LDAP, Active Directory, whatever he has. Object storage and block storage, of course, because Kubernetes and all workloads need storage. Yeah, that's also the central point of the storage. An upgrade point, which is great. You can upgrade whole stack. I don't mean the upgrade of the cluster. This is automatically done. You can upgrade shoot cluster without on the fly, and just by clicking one button without doing anything else. But I mean the upgrade our solution release, yeah, that garden stack release. That we, for example, add there some feature, and we want to upgrade all these controllers which are responsible for this feature. Then we can use just deploy or install on central cluster, and he automatically populate everything to others, to all gardeners, because one central cluster could have more gardener cluster, one gardener cluster could have more seats, and seats has shoots, of course. Yeah, and everything is going from the garden to the shoot. And you don't need to upgrade all levels of the stack. Okay, maybe this is not from the project, but from my side, why I think this project is good for me, or why I am working on it, beside of money, of course. I think we are using DevOps style of working, which is, I think, currently very popular, but I like it, because everything is based something working and it's deploying. There's just one button. It's, for me, miracle. If you are sure that it's working, you don't believe when you see it really working. Yeah, that you're impressed. As for me, mostly open source tools. I have Linux background. I was Linux administrator and Linux engineer later, and for me, open source is the way of thinking. yeah, to share information between people and to get what you want. Yeah, it's kind of communist idea, yeah, to take what you want and everyone is on the same level. But this is a little bit different, that you can share your knowledge and take knowledge of someone else, which I think moving our society and also the technology to the next level. And this was the, I think, engine of this. Touch with Golang. Of course, I'm not a programmer, but when you work in IT, every time you need to do something with programming or something similar. And I actually, in some way, I like it, yeah, to make something more automate, to create something new, which is like application or feature. And we are using most Golang, which is also a challenge for me. I was never programming in Go before, but I think you need to every time learn something new to be up to date for this area. New areas, like was mentioned, yeah, totally new area, confidential computing, for me, of course, maybe for you, for some of you know, but for me it's totally new area and very interesting how they are thinking about every detail and how to try to secure, encrypt everything inside of the memory. And yeah, that's the minimalism in this way, and this is for me also interesting. And automatization everywhere, as I said. Yeah, if you press the button, everything is there. It's like magic. And of course, very important, mostly that you are working for something what has really impact. It means that you are working on the project where already is customers waiting, and they are really will use these features. And this is also great that you are working something, you know, that maybe will help someone in health insurance. I don't know in which country, maybe in maybe in Germany, maybe in whatever, or maybe in police department, whatever. Maybe in some indirect sense could change someone's lives, yeah, because of information system of emergency or whatever. Yeah, that's the cool. And of course, we are using many open source tools, as you can see. I put some logos of things what we are using. I don't want to go through every of it, but everything what we are doing actually is 99% for sure is open source. Also, we will contribute to the community, and I think this is also the way, because in the last times or past times, there was every company was securing their secrets and no one should touch their technology. Just and in nowadays, I mean, if big corporate comes to idea, put everything to open source and be open, that's the, I think, good way of thinking and working. Okay, maybe I will try. I have 13 minutes. I will show you some small showcase on my laptop. Hopefully, hyperscalers will work because there is running my load. Maybe I will ask colleagues to switch. I will log in and then. Okay. Here you can see, this is the just viewer of the Kubernetes cluster. Here is one stack. This is the central cluster, which has, as I said, some nodes which are deployed in one of the hyperscalers. This is the garden cluster, and when you go to workloads and go to pods, then you can see that there is deploy seed. That seed has some namespace where are just some information about deployer, who is deployed. When I apply the object as a seed cluster, he will put deployer on behalf. There are some Terraform or whatever script which is deploying the things, and then these seed clusters on the way. Yeah, and then you can check pods, and there is also namespace, and there are shoots. Yeah, as I said, the control plane, Kube API server, and so on. And actually, these are the shoots. As I said, Garden cluster has more options how to control. One option, how to control the whole shoot actually, because seed is behind the scene. Seed is not the cluster you should see. Customer should see Garden, which he communicates to, and shoots, which is his workload. Let's imagine when we have two shoots. They are different versions of the cluster. And also, what is the advantage? Reconciliation and checking everything, if it's everything up to date, is running automatically every few minutes or maybe seconds, not sure. Let's take, for example, this is the cluster 11. Yeah, they have 2 nodes, and this 12 has 1 node of the workload. There could be more, and of course, and let's imagine that we need more worker than R2. Okay, then I go to this, to shoot cluster, to YAML, yeah, of course, because it's Kubernetes object. Go to part where I define the replicas. It's on the bottom. Maybe you can see there is maximum and minimum. What is also a feature of the shoots, which I didn't mention, that you can specify range, which means he will deploy minimum, but if load is bigger, automatically add next worker till maximum. If I put, for example, minimum 2 and maximum 3, he will deploy 2, but if the load will be higher, automatically generate third worker. Yeah, that you are not limited, you have no static number. Let's imagine that we have put 2 and save. And check, cluster starts to be reconciled. He's checking, okay, something happened, and trying to, let's watch the nodes. What is happening now, of course, he's activating the deployer, which is sending Terraform, okay, to the hyperscaler to create another machine. There is Garden Linux, as was mentioned, with some software stack, and this will join automatically to the cluster. Hopefully. Okay, sorry. Yeah, he's going. Probably, yeah, it's taking some few seconds till he will create a machine inside of the hyperscaler. This is probably this thing. Okay, but maybe we can watch. What other functions which it has is, of course, for example, from here is this hibernation, what I mentioned. Maintenance window. You can set when your shoot should be upgraded. For example, you know that if I will upgrade some shoot cluster, I want to do it in the night. Okay? And you can set, and it will allow to upgrade. It will wait for upgrade until this time will happen. Reconcile, which means check the cluster if everything is okay, like recheck. Rotate kubeconfig. Let's imagine that you need to provide kubeconfig to some external company which installs something in your cluster, but after that, you want to be sure that they have no access there anymore. You just rotate kubeconfig. It will create a new kubeconfig with new certificates, and then you can use it. And others are invalid. Yeah, for example. Of course, you can use SSO, but just explaining. And of course, delete the cluster. Okay, now you can see we have another node. It happened. He will create another node, and he will set it taint just to not put workload until he is ready. And then he is ready. It takes, I think, 3 minutes. It was 3 minutes. Yeah? And then you can use 2-node clusters. And of course, the same way, you can also, let's, for example, we have some time to check another thing. Let me go. Okay, doesn't matter. You don't want the more nodes you want, just the nodes should be bigger. Then you go again to the clusters, YAML, and just change the flavor. Yeah. Of course, the flavor names and these things are changing, depends of the what is the infrastructure now, and we can change it to for which should be, I think, higher memory. There is 4 gigs and should be 8 gigs. And let's check clusters. And again, it's reconciled. And when we check how it's doing, when we check current status, there is 4 gigabits memory and 2 CPU, and should be 8. It takes some time. That's, I will explain. It will create another node with a higher, at first he will disable shadowing to not put any load to the current node, and then create a new one. The existing workload is still there. Yeah? And then create another node with higher flavor, and then just switch to this node. Okay. It takes some time. Yeah, we need to wait a little bit. You see that the pods are still running. Yeah, even if there are work behind. We can see that it's 83%. And then you can change also, of course, more things like this. You can change many parameters which you want, and very easily. Of course, now it's through the YAML. Later, maybe we are still in development. There will be some dashboard, nice dashboard when you click and just change things. Yeah, but this is the minimum. If this functionality is there, just to create some button, it's not a big deal. Yeah? And of course, how we are deploying this stack is through the pipelines. We have deployment pipeline in GitLab, where you have some preparation stage, preparing some variables, YAMLs, everything, and then just create a central cluster to the installer, which is created in Go, then test central cluster if everything is okay, then garden cluster as an object in central cluster, then seed as an object as garden cluster, that just kubectl apply. You are creating YAMLs and just kubectl apply. Of course, there are some, because you can deploy more objects or more gardener cluster in one central cluster. That, of course, there are some logic. Yeah? If there are more, then do some for thing, yeah, and so on. That's this is the main reason. Yeah? And after every job, there is test, which is testing if everything is okay, and we can go to the next step. And of course, this pipeline is going also to the sheet, and then you can delete also or your stack if you want. Yeah. Let's check our node. What is happening? You see that there are two new nodes. Let's check if really they are bigger. They should be. If I did make a mistake. Okay, you see there are 8 gigs. Yeah, and both nodes are on the fly, changing their flavor. You don't need to add worker, migrate. Okay, migrating is automatic, but everything is automated. You don't need to care. Just customer, you don't need to even, you as a provider, you don't need to do it. Yeah, just customer click or change YAML, whatever, because at the end, Gardener dashboard is doing nothing else, just applying the YAML. Yeah, like it's Kubernetes, everything is Kubernetes. And then you have 2 nodes. It was taking, I don't know, 2 minutes, 3 minutes. Yeah? And that's what we want to reach, that everything what is possible to put to customer, to make it automatically, to have as less operation as possible. And of course, there on top will be some features like Kafka as a service, Postgres as a service, and these things which you maybe know from the other hyperscalers. And of course, sovereignty, confidential computing, which was already mentioned. Okay, it's just small showcase because we have limited time. But for people who are here, you can contact me and we can talk if you are interested to see more things, how is working. Then I'm open to discussion. Okay, that's all from my side. I have 2 minutes, but my colleagues before was a little bit longer. Then maybe he takes me, and I will give you back these 2 minutes.